Hi everybody, I would like to discuss about A-level physics in this video. Okay, let's find out. This is a PDF file of A-level physics. Let's see topic. And there are 4 topics in this book. And topic 1, topic 2, topic 3, topic 4. Like this. And mathematical skills representing for your examination, simple exam answer. Okay, I will discuss all about this topic only. In topic 1, mechanics, motion, topic 2, material, and topic 3 is wave and particle nature or light, and topic 4, okay, where's topic 4? Oh, I see. Electric circuit. At first, I want to discuss about topic 1. Topic 1 is motion. And before topic 1, we must understand about standard units in physics. And this is A-level physics, so I don't want to explain about standard unit in detail. At first, we must understand about physical quantities, and we need to know what is physical quantities. Yes, physics is the subject we study energy, matters, and natural phenomena. We know like this. So, if we study about energy, matter, and we must measure something else. Every matter have the features that we can measure. So, and this is a tablet. It has many features to measure. Okay, this is the length of the tablet. And this is physical quantities. And we can measure this length. And this is the weight of the tablet. And this is also a physical quantity because we can measure these. And it has mass. So mass is also a physical quantity and we can measure. So everything that we can measure about the objects and they are physical quantities. And at first we must understand about physical quantities of the objects. So the units and standards are very important in measuring physical quantities. And because we should use the exact unit in measuring physical quantities. There's many different units in the world. In Myanmar, we have the tra, the down, and their unit, but they're not exact unit. There's many error because we can define the tra. The tra is the distance between this part and this part. So it can vary for everybody. This is not exact value. And we can use this type of unit in physics. We must use the exact unit and such as meter. At first, meter is the distance between the 2 points of platinum iridium alloy and We can call this is a standard meter bar. It is kept in the temperature control room. Nowadays, we can use the unit of distance, which is based on the speed of light. Okay, I will show you. It's lagging. Please wait. Okay. I will skip 1 and 2 standard unit and estimation in my videos. So I will start from mechanism topic 1. You should study about standard units in physics because I think they are learned in IGCSE physics. So I will show you a standard meter bar. Oh my God. Oh, this is a standard meter bar, and there are 2 points on this bar. So the distance between these points is 1 meter, and it has exact values. And in Myanmar, the unit trotted down are not exact. So in physics, we must use very, very accurate unit to get accurate measurement. So they are SI unit. Therefore, we will use SI units only in this textbook, right? So I will skip this topic, and you should learn yourself. Okay, let's start about motion and mechanism. At first, we should understand what is mechanism. And mechanism in physics, mechanism is not about machines. It is about motion. In engineering, mechanism is about machines and any other apparatus. But in physics, mechanics is a branch of physics we study motion. So there's a two branch under mechanics. This is kinematics and dynamics. And kinematics is the describing motion, and dynamics is the explaining motion. So in kinematics, we will discuss about what types of motion and how to move an object and various kinds of motion. In dynamics, we will learn about why the object moves, and we'll explain why the object moves. Okay, motion. At first, I will write down the definition of motion. I think there is no definition about motion in this textbook. So, motion in general, motion is the change in position. If the objects move, it changes the position. So motion is the change in position over time, or the change in orientation. Oh, oh no. The change in orientation over time. Let's consider a particle move from point A to point B like this. This is motion because the position of particle changes from A to B over time. In motion, if the position changes, the time also changes. In this case, the particle starts from the time t1 and move to B, and it stops at time t2. In this case, t1 and t2 is not equal. In every type of motion, there is no such case t1 is equal to t2. This is the meaningless for the motion because for every object, it may take a time to move from point to point. The object should take a time for every cases because the particle cannot exist at 2 points in the same time, right? And the change in orientation. The change in position is motion, and the change in orientation is also motion. We can consider the movement of a fan like this. Let's consider this is a fan. The fan move for clockwise direction like this. In this case, the orientation of the fan changes over time. I'll draw a line. And this is a horizontal line. So we can measure the degree. This is theta 1 and this is theta 2. So in the case, the angle changes over time from horizontal line. So we can call this is angular motion, and we can call this is translational motion. In A-level, I think we must learn translation and both translation and motion and angular motion. Okay. I think the angular motion were introduced in bulk 2, and this is student bulk 1. In student bulk 1, the translation and motion only. We will learn translation and motion only. In student bulk 2, we will learn angular motion. So this type of motion will be learned in student bulk 2. And the translation and motion this translation and motion. Okay. Emotion. We got many physical quantities. Let's consider this is point A and this is point B. The object moved from point A to point B. In this case, we have a path for motion. This is the path of motion, and namely S1. And the another particle move from point A to B like this. And this is the another path of motion, S2. So in motion, we must have a path to change the position. This is essential condition because the position of object cannot change without any path. So in motion, a path is the mandatory condition. Okay. So we can measure the length of the path as 1, and we can measure the length of the path as 2. So what is this? And we can call the length of the path is distance. Distance. Distance is the length of the actual path that the object moved. I will write down the definition. Distance. Distance actual path that the object moved. We have the distance. There is no motion which does not have the path. Okay. And we have the time taken. And we can take a ratio distance to time taken, and it make we can get speed. So in this bulk, it starts from the speed. Speed is a quantity. We which describe how the object fast. The object is fast in moving. One of the simplest thing we can measure is how fast an object is moving, and this is the speed, and speed is a distance over time. Let's consider an example. The object moves from point A to B. S1. This is distance 1. And another object moves from point A to B like this. This is the object 2, and this is S2. So the starting point and end point for both objects are the same, but paths are different. And the first object takes time taken as T1, and the second object takes time taken T2. Let's substitute some values. Let's say S1 is equal to 1 kilometer, and S2 is equal to 2 kilometer. T1 is equal to 1 hour, and T2 is equal to 1 hour. Which object is faster? And we can say simply the second object is faster because it can move a longer distance at equal intervals of time. Okay, so the second object is faster. How can we say like this? We can measure the speed and to say which object is faster. So in mathematical, we can take a ratio of V1 is equal to S1 divided by T1, and V2 is equal to S2 divided by T2, and we can get the speed. And since the distance is a scalar quantity, the speed is also a scalar quantity because the distance is the length of the artery, but in definition, length is a scalar quantity. Length scalar. And we need to consider the direction of motion for distance travel or distance. Therefore, distance is a scalar quantity. The direction is not important in measuring distance. Time taken is also a scalar quantity. So the speed is the length divided by time taken. We have scalar divided by scalar. So we can get scalar quantity only. Therefore, we can say the speed is a scalar quantity. And then the unit of speed is meter per second. And you can say delta S divided by delta T is also, sorry, delta S divided by delta T is, that is, the velocity. And the velocity is better quantity. Okay, I will discuss about velocity in next video, and I discuss about motion and distance and speed in this video. Okay, thank you so much.